Okay, so let's do the following. Let's review very quickly, okay? So yesterday I posted a video about the halfway rectifier that I recalled it. I know sometimes it's hard, you know, to sit down and watch a video about anything at all. But I guess that, I mean, I was only thinking, like, if that was going to be something that could be useful to you.
Mm-hmm.
So let's do the following, okay? So the last time when we were together, we covered the halfway rectifier, full wave, and also the bridge rectifier. After that, you went to the shop and you completed your lab. Okay, so what we are going to do here, let's just review pretty quickly. I don't remember actually, like, if we had a chance to do the review questions together.
I don't think we did.
Okay, so let's do that. Let's do the review questions together. And once we do the review questions together, that's going to help us, whatever, like, go forward into capacitors. Is that something that you are willing to do this morning?
Sure.
Yeah, let's give her.
Okay, so I gotta put you on mute, and then we're gonna go ahead and do that. Like, and actually, you can use the. Okay, you can use. I mean, if you need to talk at any given point in time, just unmute yourself. Okay. Okay, so let's begin. Okay, so here, I just got to make sure that. Okay, perfect. So let's begin here. So what is the peak voltage of a measured RMS voltage? Something which is important here. I want you to be able to remember that this RMS voltage that we have right there, it is the effective voltage of your AC sine or your sine wave. This is also called effective voltage. That's something important to remember, and that's going to be, you know, part of your quiz. So in that instance, let's do a let's see how we can do it, you know, together. In this instance, when I ask you, or when the question is asking, what is the peak voltage of the measure, 250 volts? So what we are going to do is that, I mean, if you want, you can answer the question. If any of you want to offer the answer, that would be
353.55.
Oh, that's good. Thank you. I know you're alive.
That's
So
right.
353.55 volts. Okay, perfect. So let's get moving. Like, what if I wanted to know the peak-to-peak voltage? What do I multiply by?
Take the 353 times 2.
Perfect. So if that was going to be the E peak to peak, then I just multiply this times 2, and then that's going to be my peak to peak voltage. Perfect. Now, let's get moving. Okay, so I'm going to have to clear this. So what about this one? How long it takes for one cycle to happen when the frequency is 120 hertz? How do we do that calculation? Do you remember that one?
The inverse of 120 hertz?
Perfect. Yeah, because we have that frequency. Okay, we have that. You'll get back to this. This is giving me some issues, but not that. So we have that frequency is equal to the inverse of the period, and also that the period is equal to the inverse of the frequency. And that's also important to know, okay? So please try to remember those. So in that case, what was the answer?
0.0083 seconds.
Perfect. Now, it is good that you mentioned the word seconds here, because second is going to be the unit which is used for the period. Oftentimes, when you are using the oscilloscope, you are going to have, you are going, because of the scale that you are using, your scale is going to be either in milliseconds most of the time or microseconds. Because of that, it is important to convert those milliseconds or microseconds to seconds, because period is always used in the formula in seconds. And I mean, that's the unit of time in science anyways, the second. So let's do the next one. What about this one? Where the oscilloscope shows whatever. You can read the question, I don't have to read it for you. So in this case, our peak voltage is, okay. Our peak voltage is 200 volts. Now, remember that on the oscilloscope, whenever you have peak voltage, how many of you have been able to use the measure function from the oscilloscope? Have you been able to use that?
Yeah,
I mean,
we used it in the last lab.
okay, perfect, perfect. That's good. Because, I mean, when you use the measure function, on the measure function, the value, do you know what is called on the oscilloscope, that peak value? The peak value, it's called max on the oscilloscope. Because you have, and at this point in time, you are not, what you are going to be using the max for the peak voltage, but also, let me just draw this for you. Okay, here. You are going to have your sine wave. Now, on your sine wave, of course, you know you can use the horizontal line in order to determine what's going to be your voltage. Excuse me, not the horizontal, the vertical line, like that, okay? So you can use the vertical line to determine how many volts divisions you have. Like in that instance, this is my horizontal line that measures sine, and this one measures voltage. If I have 5 volts per divisions, from the oscilloscope, from the screen of the oscilloscope, we'll be able to see that we have indeed a peak voltage in that case, which is equal to 10. Are you okay with that?
Yep.
Yep.
Now, in that case, what would be my minimum voltage? Okay,
Would it not be
minimum
negative
voltage.
200?
Okay, so in that case, yeah, I mean, as I am pointing on the screen, the maximum voltage that you have from this halfway signal,
Oh, it'd be 0.
is going to be 10. Okay, that's going to be your peak, which is your max.
I'll put some gas in that, bit more gas in it tomorrow.
Sorry, I lost you there. What did you say?
Sorry, I just got lost there.
Oh, I got you lost?
Well, the little feedback from someone else kind of.
Oh, okay, okay. So I was saying that, like, this is a halfway
Oh, okay.
sine wave, half wave, right?
Yeah.
And then your peak voltage, because we have 5 volts per division, your peak voltage in this case is 10 volts peak. Now your minimum voltage, the minimum is going to be equal to 0. So you will see that the oscilloscope on the measure function, it has the max, that means peak, and also has a minimum value, which is called mean. Now, in the last lab that you were doing, you were not using the minimum value. Why? Because you don't need it. However, as you move forward, that minimum value is going to be something that you can use in order to determine your ripple voltage. So let me show you another formula that you are going to use. And it's a formula, I mean, it's a valid formula that you can use in order to determine your ripple voltage. It says that your ripple is equal to the E max minus the E minimum divided by 2 and multiply by 0.707. Okay. So as we go forward and we use capacitors, this is a formula that might come handy. Fair enough?
Yep.
Okay, so let's keep moving anyways. Let's try to do as, let's try to move through this as swift as possible. So like if we have 200 volts peak, okay, like to determine the peak-to-peak value, we already know what we gotta do. E peak to peak, E peak times 2, we already said that. And that's gonna be equal, we know, to 400 volts.
Yep.
And then what about the RMS value? How much it was?
141.4.
Okay, perfect. So it was the E peak. And then something which is important to know, because sometimes people get a little, I mean, like you get a slightly different results, is that, I mean, when you multiply your E peak times the sine of 45 degrees, which is the 0.707, or if you take your peak value and you divide it by the square root of 2, in both cases, you are going to be getting approximately, I mean, the same answer, okay? So any of these two formulas can be used to find your RMS voltage or vice versa to find your peak voltage. Now, any questions about that? No questions?
Nope.
Okay, so you're good there. And then it is important, you know, that we remember once more that the word average means DC. Okay, that DC is not always perfect because as we were seeing here, if that was my DC signal, this is a only half wave. And even if I have a full wave rectification, still I'm going to have a DC signal which is not perfect, which is not completely flat. So this is called a pulsating signal or pulsating DC. Okay, no questions?
Nope.
So anyways, I just hope that I don't get you bored, you know, with all this. I guess that if we were in the classroom, it would be a little bit easier because we can have more interaction inside
I
the
mean,
class.
I'm still laying in bed watching this, so it's pretty good.
Oh, okay, perfect, perfect. It's good to
I'm
get some
still
kind of
taking notes
feedback.
though.
Don't fall asleep, Logan.
Yeah.
Okay, so the average voltage, when we calculated this, it was, we were taking, of course, like you have two different choices for this, okay? But I prefer to use my RMS, my recommendation, so you don't have to memorize the other formula, is just to use the RMS voltage. Oh, this says it's a full wave here. And multiply by 0.9. That's gonna be the easiest one. Also, you could go, I mean, you don't have to learn the other formula, which is like that E average is equal Give me 1 second. That's the only thing different, you know, like whatever. Sorry about that. That wasn't good. I'm just trying to delete. Okay, I found it. I'm gonna delete this so I can create some space.
If I used E peak times 0.637, that'd be the same
Perfect.
thing, right? That's just the
It
other
would
one.
be the same thing. That's what I was going
Okay.
to say. Absolutely. You're right.
Okay.
So it would be E peak times 0.637. So we can use either of the formulas we used. We are going to be good.
Okay.
Okay, so keep moving.
Yep.
Okay, so let's get to this one. A DC meter taking a reading that it is 150 volts. Now, the reason why you have this question that it tells you that you have a DC meter, well, you took a voltage reading of 150 volts. What is the peak value of this sine wave?
Would it be 150?
Why is that?
Because DC doesn't have a, it's not actually a wave, so whatever the meter's reading is the peak voltage.
Perfect. So when we have the oscilloscope, right on the oscilloscope, if we know that if we have AC, this is what we have, right? But if we have DC, we have a straight line. And because of that, I mean, we don't have an increment. Whenever we turn on or whenever we apply a DC voltage to any circuit, we are going to have a fixed voltage that never changes in magnitude or polarity. So yeah, you are completely right. It's going to be 150 volts. Anyways, can we keep moving?
Yeah.
Yep.
Okay, so let's keep moving. Okay, so an oscilloscope is set to 5 milliseconds divisions. One cycle stay 3.5 squares. What is the frequency of this signal? Do you think it would be easy just to say, well, if we have 3.5 squares, we multiply our 3.5 squares times the 5 milliseconds
Yep.
in order to get the total time, right?
Yeah.
How much is it going to be in this case?
17.5.
17.5 milliseconds. Now, these milliseconds, we have to convert it to seconds. So we are going to be taking our decimal point and skip it 3 spaces to the left, 1, 2, and 3. So in reality, we have 0.7175 seconds. Now, what's going to be the frequency? I know that that's not in the question, but at the end of the day, that's going to be the objective, to be able to determine our frequency.
$57.14.
57.14 hertz. Perfect. Thank you. So let's get moving. So if we had a peak-to-peak voltage of 880, and then this is an important question, okay? Because here we have a peak voltage of 880 volts. That's the peak-to-peak voltage. And then this is going to be put through a bridge rectifier. Now, it is important that we know the difference between a bridge rectifier and just like a full wave rectifier. Remember what's the difference between the two, bridge and full? Any ideas?
Yeah, one has 2 diodes and one has 4.
Perfect. So which one is 2 diodes?
The full wave.
The full wave rectifier. So what's going to be the catch? I mean, because which one is going to allow us to save more money, the bridge or the full wave?
I'm gonna say the full wave.
Okay, so I'm going to take you back pretty quickly, or just for a second, to the diagram itself. I'm going to take you back to this diagram. So I want you to notice, are you following this on the computer? I guess you are, right? So I want you to notice here on this diagram that we actually have, okay, we have this, the center tab. We are using the center tab. So that would mean that if I want to, if I want to have the voltage that I'm going to have right here on my light bulb is going to have to come from line 1 and also line 2. Okay, so that means that I will need to have a center tap transformer where the center tap is going to behave as my neutral conductor. That means that I'm going to be spending more money because I will need to have a second windings in order to be able to have the same voltage that I would obtain by having a bridge rectifier. And anyways, like electronic components like diodes, they are cheaper than wires.
So the full bridge is cheaper then, is what you're saying?
Yeah. That's what I'm trying to imply.
Okay.
So here we have the here we'll have the bridge rectifier, and now you can notice here that indeed we are using just 28 volts, but we are using only line 1 and line 2. We don't need the center tab anymore. And then when we multiply our 28 times 0.9, that's how you were able to obtain your voltage. Oh, well, that yellow, I don't think it's going to be so good. Okay, so that in that instance, 28 times 0.2, yeah, you would get 25.2. And that's going to be called, you remember the name for that voltage?
Average.
Average. Okay, so you can say DC average or average DC or just average voltage. Okay, perfect. So, okay, so let's finish the questionnaire. We don't have so much time left. I mean, I booked this for 1 hour just to gather your impressions, just to see how this was going to flow. And it's not too bad.
Better than nothing.
Yeah, better than nothing. That is true. I'd rather be the classroom, to be honest with you, but
hey, it's better than retaking level 2, so I'll take it.
Oh yeah, that's true. That's true as well. I like that. You keep a positive mental attitude.
That's right.
Way to go, Don, in these rough times.
Okay, guys. So let's keep going. We were doing question number 6. Let's do this quickly, okay? And then I'm gonna be posting the capacitors PowerPoint. You can review it. And then next week, when we do capacitors, I mean, we could do it this week. We can come to an agreement before the end of this class. And we'll do whatever we agree to do, okay?
Okay.
So, as I was saying, we have 880 volts. That was the peak to peak. The first thing that we need to do.
Divided by 2 to get just the peak.
Perfect. So that's going to be 40 volts, right?
Yeah.
And now that we have 440 volts, that's my peak voltage.
So you multiply by 0.637 again to get your average.
Okay, so something which is important, like, yes, we can multiply by 0.637, and that would be the usefulness of knowing the 0.637, that we don't really have to convert it to RMS in order to get our average voltage. So how much do you get for that?
280.28.
And yes, that's going to be DC. Do you remember how we call this DC? That's
Pulsating?
pulsating DC. Now, there's another component to this pulsating DC. This pulsating DC, it has, even when it doesn't change in polarity, is changing in magnitude. So it has an AC component to it that we call ripple.
Oh, this is the E ripple. Okay.
Okay. So, and if we want to calculate this ripple, do you know any, like, okay, I'll just tell you, okay? So if we want to calculate this ripple voltage, we do E ripple. I show you one formula, but I'm just gonna show you like a more simple ways to do that calculation. It's gonna be the E ripple is gonna be equal to the ERMS
Times 0.43.
times 0.43. Absolutely right. Thank you. If you had a halfway rectifier, it would be times 0.54.
Yeah.
Okay, good. Okay, so let's get moving. You're all great, guys. You're doing a great job, making my life so easy, making everybody else's life easy. Thank you for doing that. Okay, so what about question 7? What will be the input? What will be the input AC voltage into a halfway rectifier to get 12 volts? Now we're working backwards. We're working from the point of view that we know how much DC voltage, how much average voltage we want, right?
So is the input AC, that's what, that'd be your peak? Are you trying to get?
What you are trying to get, okay, so this is what you want, 12 volts, right?
12
Yeah.
volts.
And what you are trying to get is what's going to be the value of your transformer, pretty much. I mean, the value of the secondary side of your transformer.
So you want an RMS then?
Yes, perfect. That's what
Oh, okay. So I got it wrong then.
so your ERMS.
Do you just divide the 12 by 0.54 or?
That's what I thought.
Okay, so let's do this, okay. Let's do the following. So if we have, okay, this is the formula that we have for RMS. It says that E average, excuse me, is equal to the ERMS times 0.9, right? That's the formula that we have to get the average value. So we just transpose that formula, and when we transpose it, this value that is multiplying will go to the other side of the equal sign, doing the inverse operation, which is dividing, right?
How come? And I'm just looking at my notes here. I got that half wave rectifier, and it says underneath.
Oh
that the
yeah.
average-
Sorry. Say half wave. I was missing that.
So it's times 0.45, right?
Perfect. You all completely right.
So you
My
divide
bad.
by 0.45 for this one.
Yeah.
0.45. So how much is what's going to be the answer?
I'm just doing-
26.66.
26.66 volts. Perfect. So it was a matter of just transposing or just moving this 0.45 to the other side, doing the inverse. So I'm going to rewrite it. Perfect. Okay, we're good there?
Yeah.
Yep.
Okay, perfect. Let's keep moving then. What about question A? The peak-to-peak of an AC sine wave is 4.5 divisions tall. Okay, so that means that okay, so we got our peak-to-peak. That's not gonna work.
So
So
I just
it's like, yeah. Tell me, please.
I just went 90 divided by 4.5.
Why do you use 90? Oh, okay, because you have okay. You have 90 millivolts, right?
Yeah.
So, and you needed the
Oh, I got that. Oh, okay. I see what I did. Yeah.
So you want to divide
I
it
would
by
have to
2
by
because it's
9.
only 4.5 divisions tall on like half the wave then.
Yeah. So wouldn't it? Yeah.
And then divide
No,
that by 4.5.
Right. Or divide it by 9.
Yeah.
If I took 90 and divided it by 9, because that would be the entire thing, right?
okay, so you got to be a little careful here, okay? Like the question reads, my understanding, I am reading the question that says that the peak-to-peak of an AC sine wave is 4.5 divisions tall, right? So that means that from this peak to this peak, we have like 4.5 divisions in total.
Oh, okay.
Okay, because remember that the oscilloscope, I mean, you wouldn't be able to get like 4.5 divisions, I mean like length on the vertical alignment because you only have 4 divisions. Remember that from the screen? I
Oh,
mean,
so I was right then.
yeah. So it would be a matter of dividing, like you are gonna have like here, 2.25 on that side. Okay, 2.25 divisions. And then 2.25 at the bottom as well. So what should be the volts division? It would be 90 divided by 2.25, pretty much.
Wait, why would it be 90 divided by 2.25 if
Isn't
its
the peak
peak
to
to peak is 90?
Oh, sorry, 45. Okay. So either way we do it. So it's gonna be 45 divided by my 2.25. And it had been the same, like if we had done the 90 divided by the 4.5.
Oh, okay. Okay.
Good point.
In either case, we would be getting the same answer, the same amount
Yeah.
of volts per division. How much
20
is that?
millivolts. 20 millivolts.
Okay, 20 millivolts. Perfect. That sounds good. Okay, can I get moving?
Yep.
Yep.
Okay, so that one is easy. I think it's easy, right? So
Yeah.
far,
Yeah.
how long is one cycle? If the frequency is 380 hertz. How long means t? It's time, period.
1 divided by 380.
You are absolutely right. So how much is that?
0.00263 seconds.
Perfect. Okay, let's get moving then.
This one I didn't get. I didn't know how to do it. Number 10.
Okay.
Wouldn't it just be the average is 0.637 and 360?
Okay, so that's okay, so I'm gonna show you that, okay, guys?
Yeah, because it says no rectification, so I didn't know what.
Perfect, perfect. So let me show you that quickly. So what I'm going to do here. Okay, I keep doing this. So I'm going to. Okay, my bad. I'm trying to be fancy and. Okay, this is your. That's your vertical line. Okay, and then you got your sine wave. So remember, this is a positive signal. Let's say that one is 10 volts. And this is a negative signal. That one is also going to be 10 volts, right? 10 volt peak on either side. Now, if you used a DC meter, because when you want to measure the average voltage, you are going to use a DC meter.
Oh, right, because average is DC.
Perfect. So how much will the meter read?
Oh, 0.
Perfect, because plus 10, or in this case, plus 360 minus 360 is equal to 0. So we don't have any DC in an AC signal.
That was a trick question.
Okay, let's keep moving. Oh, that was it. That's the end of it.
Yeah.
Okay, so